Hello, my little mathematicians. I'm going to help you get started on the mods 9 and 10 study guide for our test. Okay, so it should say VL-1044 on it, and it looks like this. Let's go ahead and get started. Remember that you can always pause the video, try it yourself, and then unpause it and come back to check yourself. Okay, for 9 squared, what did you put now that you're back with us? It's not 18 because it's not 9 times 2. It's 9 times itself 2 times, which is not 18, it's 81. Okay, 9 times 9 is 81, right? All right, for our next one, number 2, this is not 10 times 4, it's 10 times itself 4 times. 1, 2, 3, 4. Okay, so we have 10 times 10 is 100, that 10 times 10 is 100, and 100 times 100, well, what's 1 times 1? 1, and then tack on 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Your comma goes there, so it's 10,000 for that one. Okay, for our next one, 28 to the 0 power. What do you think? Hopefully you said 1, because anything to the 0 power is 1. And if you're asking yourself why, let's take a look at 2 being raised to a power and 3 being raised to a power to kind of see why that works out. Okay, so 2 times 2 times 2 is 8. 2 times 2 is 4. And 1, 2 is just 2. 3 times 3 times 3 is 27. And 3 times 3 is 9. 3 to the first power means just 1 3, so it's 3. Notice that each time you move up, you're multiplying by your base. So here's a base of 2, and each time I go up and I get bigger, I add on another number, or I add another exponent, it's getting multiplied by 2. 2 times 2 is 4. 4 times 2 is 8. And same thing here. I'm adding another base each time I add another exponent, so I'm multiplying by that base each time I move up. 3 times 3 is 9. 9 times 3 is 27. So if each time you go up, you're multiplying by the base, then the opposite, each time that you go back a step, you divide by that base. So 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. So that means when I back up one more exponent, I get 3 to the 0. So 3 to the 0 power is 1. Back up here, divide by 2 each time. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So if you back up a step, 2 to the 0 power is 1. Anything to the 0 power is 1. This is why. Okay. Right here, you have 5 times 5 times 5, because there's 3 of them. Well, 5 times 5 is 25. Bring down that other 5, and let's multiply that out. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12, so you get 125 for your final answer there. This one says write it in exponential form, so you're going to take your base and raise it to a power depending upon how many of them there are. So 1, 2, 3, 4, 5 14s. So 14 to the 5th power. I technically don't need parentheses. I could have just had it like that. 14 to the 5th power. Just make sure that 5 is up top and it doesn't look like 145. Okay, now that's a little bit different than this one, because this one, if you put 4/5 to the 3rd power like this, you're actually not right, because this right now is saying 4 times itself 3 times and just a 5 on the bottom. That's what this is saying. If you put it in parentheses, now it's saying, oh, the 4 is being cubed and the 5 is being cubed. So the 5 is times itself 3 times as well, which is what this is saying. It's 4/5 times 4/5 times 4/5. So the parentheses matter for this one because it's both the 4 and the 5 that are being cubed. This one, it doesn't matter. You could have parentheses or not have parentheses. All right, for our next one, again, remember, please be trying these on your own first. Pause it and then unpause it and come back to check yourself. Quotient means divide, and 18 comes first, so it goes on top. And a number, you can use any number you want. I'm going to use an X, but you could put an A, a B, a C, whatever your little heart desires, so long as it's on the bottom. Okay. If you wanted, sure, you could have written it like this and let's put in H, okay? It could be any variable just so long as it goes 18 divided by some letter, okay? Either of those are fine. This one says the difference means subtract, a number, so pick any number. I'm going to pick an X. And by when I say any number, I mean any letter, any variable to represent an unknown number. And 12. So after the word and, this goes on the other side of my plus sign. So you could have C minus 12, B minus 12, Q minus 12, as long as your letters first minus 12. When it's the difference, it goes in exactly the order it says. Okay, again, we have the quotient of a number, so some unknown number, and 11. Okay, or you could have written it like this. Either way is fine so long as your variable comes first and the 11 comes second, just like it's specified. Okay, this one, difference means subtract. The difference of what? 2 and a number, so 2 and some unknown number, divided by 3. And you're like, actually, what does that mean? So it's that right there means 2 times X, right? And the way that this was written, it actually kind of helped you catch that mistake. Because did it say anywhere in there that it said 2 times a number or the product of 2 and a number? No. And that's how I wrote it. So I did that kind of on purpose. But this one was nice that it let us catch that mistake. But here, when you see the word difference, I mean minus, 2 comes on this side of the minus sign. And after the word and, that's what goes on the other side of your minus sign. Okay, so your variable is going to go here. So it's 2 minus some unknown number. It could be 2 minus B, 2 minus A, 2 minus C, whatever you want. Okay, and then it says comma. So this whole difference is being divided by 3. Okay, if you wanted, I like doing whenever I have a divided by, I like draw the fraction line, but we could have also said this, and as long as we put this here, so this whole thing is being divided by 3. All right. Okay, this one is saying 24 fewer than, so you're like, fewer than what? Some number. So you would think this, because that's what we did up here. You know, the X came first and then the 12, so it looks like this. But when you see the word than or from, it actually moves that number to the back and it changes the order, making that no longer correct. It's actually X minus 24. Okay, the 24 gets moved to the back because fewer than or less than would move it to the back, or subtracted from moves it to the back. If they just say 24 minus X, then this would have been right. Or 24 less X, sure, it would have looked like this. But if it said less than or fewer than or subtracted from, it switches the order. Okay. Right here, try this one. 8 is being subtracted from what? So we're putting the 8 minus 8 at the end because we saw the word from. It's being subtracted from the quotient, so I'm dividing something, some number, and 2. Okay, so it could look like that, or you could have said X divided by 2 minus 8. Either one of those works. Okay, the next one says James is 2 years older than his sister, Keisha. If J represents James's age, write an algebraic expression for Keisha's age. Okay, so I have Keisha is who I'm trying to figure out, and I'm representing her in terms of James. Okay, James is older, and I'm representing Keisha. So Keisha should be smaller than James. So do you think I should add 2 or subtract 2? I should subtract 2 to represent Keisha. So J minus 2 is my answer. And J is representing James's age. Okay, my next one says Amber is 4 years older than her sister Simone. So Amber is older. Okay, write an algebraic expression for Amber's age. So I'm representing Amber's age. And they want me to use the variable S to represent Simone. So Amber, I'm representing the older sibling here. So it should be getting bigger. So should I add 4 or subtract 4? I should add 4 to represent Amber. Okay. It's all in terms of how they asked it, right? All right, for our next one, it says Kai wants to go to the fair and go on some rides. Write an algebraic expression on how much Kai will spend at the fair if admission into the fair costs $10 and each ride costs $3 each. Define your variable. What do you think? Try and come up with that. Okay, well, this $10 is a one-time fee. So that just gets paid once. And then you're going to add that to the additional cost of $3 each. Whenever you see the word per, each, or every, that's usually going to get attached to your variable. And I'm going to use the variable R, it says define your variable, to represent the number of rides. Okay, so the 3 gets multiplied with your variable, the R, because it's $3 per each ride. Okay, and then the 10 just gets tacked on at the end. So you could have had it like this or like this. Either of those are fine. The 10 is a one-time singular fee, so it's a constant. And then your 3 times R, it changes depending upon how many rides you go on, and they get multiplied together. Again, when you see the word per, each, or every, that usually gets multiplied with your variable. See if you can use my hints to set up 16 on your own. Okay, pause it, unpause it when you think you got it. You just unpaused it, you're back with us. It says Chuck wants to buy a new video game for $49.99. He also plans to buy some new skins for his game characters. Each skin costs an additional $1.99. Write an algebraic expression on how much Chuck will spend on the game and skins. Don't forget to define your variable. Okay, so is there like a one-time fee? Yeah, you buy the game once and then you have it. Okay, and then once you have the game, they charge you, this is how they make their money, okay, an additional $1.99 per skin that you buy for it. Okay, so it could be like this, or you could do the 1.99s plus the one-time fee for buying the game. Either one of those is fine, and then it says define your variable. We chose an S to represent the number of skins purchased. Okay, some of those were pretty tough. We're going to go ahead and move on and keep going. Okay, and now they want us to complete this table. It says Micah always spends 3 times more studying than his sister Cass. Okay, so who spends more time, Micah or Cass? Micah always spends 3 times more. So Micah should be more and Cass should be less. That doesn't seem like a big deal, but writing that up at the top might help you later. Okay, so it's 3 times as much. So if I want to be representing Micah, should I multiply it by 3 or divide it by 3? Well, he's the one who spends more time, so my number should get bigger. So let's multiply it by 3. And 5 times 3 is 15. So if Cass spends 5 hours, Micah will probably spend 15 hours studying. And now they gave me this one, and I want to find Cass's, who studies less. So to get from here to a smaller number, should I multiply or divide? I should probably divide by 3 this time. And 30 divided by 3 is 10. Okay. So it depends upon if you multiply or divide based upon who they gave you, right? And then it says it wants you to write an algebraic expression. If C represents Cass's study time, how would you figure out Micah's study time? Well, Micah would be more, so you would multiply the C by 3. So this is the expression representing Micah in terms of Cass. There you go. Okay, our next one says find the prime factorization of 88. Go ahead and do that. Okay, pause it, unpause it, and come back and check. All right, now that you unpaused it and you're back with me, if your tree looks a little bit different, it's okay, so long as we get the same answer. I would do 8 times 11, and then 8 keeps going to 2 and 4. That's prime. 4 keeps going to 2 and 2, prime, and 11 is prime. So I have 2s and 11s, and I have 1, 2, 3 2s, and 1 11. Okay, as long as you got that answer, you're all right. But I mean, you could have done it so many different ways. You could have done 2 times 44, and from here you could go 2 times 22 or 4 times 11. Let's say I did 4 times 11. Okay, I still end with 2 times 11, and there's 1, 2, 3 2s and 1 11. Okay, so there's many different possible trees you could have gotten. If you didn't make a math error, you would have still gotten 2 to the 3rd power times 11. Okay, the next one says simplify the expression by using the distributive property. So I'm going to distribute this 6 that's out in front to each number inside of the parentheses. So I'm going to multiply the 6 times the x, bring down that minus sign, and then I'm going to distribute the 6 to the 4 as well. Well, 6 times x can't simplify anymore. It's just 6x. Minus 6 times 4 is 24. I can't combine those because they're not like terms. This has a variable and this is a constant. So I leave it just like that, which is different than this one. Okay. First off, I want to distribute that 8 to everything inside the parentheses, right? So bring down that 12 plus, this is 8 times 3x. Bring down that plus and distribute the 8 to the 4 as well. And then just tack on that plus 5x. Okay, well, 8 times 3x, 8 times 3 is 24, tack on the x, plus 8 times 4 is 32. Bring down your 5x and your 12. Do you guys see any like terms? Yeah, I see this 24 attached to an x, and then I see this 5 attached to an x. So 24 plus 5 is 29x, and then you have a 12 and a 32. Those are both constants, so let's combine those. 32 and 12 combine to make 44. Now this is a constant and this has a variable attached, so I can't simplify it anymore. That's done. Okay, my next one. I want to go ahead and simplify this just using PEMDAS. So inside of the parentheses first, the whole rest of the world just falls away. What would you do first according to the world of PEMDAS inside of there? I would do multiplication before I do addition. So 2 times 3 is 6. Bring everything else down that hasn't been used yet. Okay, I still have numbers inside of the parentheses that need to be simplified down to a single number. 4 plus 6 is 10. Okay, and now parentheses are down to a single number, check. Exponents right here, what's 10 squared? It's 100. Bring down your other items. 101 minus 100 is 1, and 1 minus 1 is 0. So final answer of 0 there after all that work. Okay, this one, inside the parentheses first, so exponents come before multiplication. So I need to take care of that 3 squared, and 3 squared is 9. Okay, I still have numbers inside parentheses that need to be simplified. 4 times 9 is 36. Okay, parentheses are down to a single number. There's no more exponents. Multiplication or division right here. 36 divided by 3 is 12. Bring down your plus 8. And 8 plus 12 is 20. You guys are just powering through this. Okay, number 23. Sometimes we say PEMDAS, and other worksheets will say GEMDAS because it's any like type of grouping, really. It doesn't necessarily have to be inside of parentheses. It could be any type of group. So I want to simplify this group on top. So let's kind of focus on that first. And so I know that whatever answer I get over there, I'm going to keep going and put that answer over 6 times 5 so that I don't work all this out and then forget that this whole other problem existed. So I have 4 plus 2 cubed. Well, 2 cubed is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8 plus 4. And 4 plus 8 is 12. So this whole thing gets replaced with a 12. Okay. Now this single term needs to be reduced right here. 12 divided by 6 is 2. And 5 times 2 is 10. There you go. Okay, for our next one, inside the parentheses first, and what comes first? Exponents before subtracting. So 3 cubed is 3 times itself 3 times. 3 times 3 is 9. 9 times 3 is 27. It doesn't take that long to rewrite it out here, 3 times 3 times 3. But seeing it and actually going through it like this versus just doing it all in your head eliminates the probability of you making a mistake by quite a bit. Okay, I still have parentheses that need to be simplified down to a single number. 30 minus 27 is 3. Bring everything else down. Okay, parentheses are down to a single number. Do you see any exponents? Yeah, this 2 cubed. So 2 times itself 3 times. 2 times 2 is 4. 4 times 2 is 8. Okay, parentheses are down to a single number. Exponents are gone. Do you see any multiplication or division? Yes. And go from left to right when deciding what to do there. So 24 divided by 8 is 3. Multiplication, division before addition, subtraction. So 3 times 3 is 9. And 9 plus 10 is final answer of 19. Okay, these are pretty tough. If you're getting these right, good job. Okay, one more page. We're almost done. We got this. It says evaluate. When it says evaluate, that means you're going to solve it. Okay, so I'm going to have this expression right here, but the only thing I'm doing is I'm replacing any time that I see a variable with what it's equal to. Okay, so this x I'm going to replace with a 5. This x I'm going to replace with a 5. And I put this one in brackets just to make sure that like this is one singular term. Okay, so this singular term simplifies to become 10. Bring down the plus 3. And then this exponent, what's 5 squared? That's 5 times 5, which is 25. All right, now when you have only addition and subtraction left, you go from left to right. So 25 minus 10, 5 minus 0 is 5, 2 minus 1 is 1. You have 15 plus 3, and 15 plus 3 is 18. Okay, for our next one, I have 2y squared. So I'm going to focus on this guy and this guy. And this is when brackets are super helpful. Okay, so this is one singular term, and this is one singular term. So I'm going to put each term in its own brackets. So here is 2 times whatever y is squared, and this term is 3 times whatever y is. Okay, y is 3, so let's plug a 3 in here, and this y is 3. Okay, this term right here, 3 times 3 is 9. So that term is now down to a single number. This term, though, there's several things happening. And if you want, you can put it in brackets. Doesn't really matter. Okay. Do you multiply or do you do exponents? Well, remember, P for parentheses means our parentheses down to a single number. Okay. No, these are not down to a single number. But exponents comes before multiplying, because this 2 times 3 is really meaning like it's 2 times 3. It's multiplication. So you take care of the exponent first. 3 squared is 9. And then 2 times 9 is 18. So this term is 18. This term simplified to 9. Now you have each term down to a singular number. 18 divided by 9 is 2. Okay, here I have this term divided by some other term plus some other term. Okay, and it's 2 times whatever n is and 3 times whatever p is. M is 6. N is 5. P is 7. So let's just focus on each term. So this term simplifies to 30. This term simplifies to 10. This term simplifies to 21. Because it's the term of 3 times 7, the term of 2 times 5, and the term of 5 times 6. Okay? And this is important because sometimes you might think to divide this number right here by 2 and then multiply it if you didn't know that you had to take care of this term first before you do the operation sign separating each individual term. And that's why I put each term in brackets. Okay, 30 divided by 10 is 3 plus 21, and then 3 plus 21 is 24. There you go. Okay, this is a singular term minus, that's already in its own group, so we know to simplify that. And then you have 5 times whatever g is. Okay, so this term is 2 times whatever e is squared. This one is 2 times whatever f is squared. So 2 times e squared, e is 4. 2 times f squared, f is 5. And then 5 times g, g is 2. And you might want to just double check that you got everything. Okay, now we're good. Let's move on. This term right here, I want to take care of the exponent first. So 4 squared is 16. Over here, again, you'd want to take care of the exponent first. So 5 squared is 25 times that 2. And then down at the bottom, that little group, 5 times 2 is 10. This can simplify. 2 times 16 is 32 minus this group up here, 2 times 25 is 50 over 10. So now you have 32 minus 50 over 10. So 50 over 10 reduces to, what's 50 divided by 10? It's 5. And so now you just have 32 minus 5. Go ahead and work that out. 12 minus 5 is 7. Bring down your 2, and you get a final answer of 27. That was a super tough one. Okay, this one is saying which of the following expressions are equivalent. So which ones are equal? And circle all the letters that are equivalent. This one I can simplify by distributing that 3. Distribute the 3 to the x, bring down your plus sign, and then distribute the 3 to the 5. 3 times x can just be simplified as 3x, and 3 times 5 is 15. I can't combine those because that has a variable and that's a constant, so that's it. This one, I see an x and I see another x, so combine your coefficients. What's 2 plus 1? It's 3x, and then tack on your constant at the end. Okay, so 3x plus 15. Here, I'm going to distribute that 2 to both the x, bring down your plus, and then distribute the 2 to the 7. Don't forget to tack on that plus x at the end. The 2 is only being distributed to the thing inside the parentheses. 2 times x is 2x. 2 times 7 is 14. And now your plus x. So this 2x and this x combines to make 3x plus 14. Okay, and then here you have an x, an x, and an x. Well, 1, 2, 3 x's. And then go ahead and combine your constants. And do the signs in front of them in case there's a subtraction anywhere, because then you would subtract one of the numbers. So 4 plus 5 is 9. 9 plus 6 is 15. Okay, again, when you're circling your like terms, include the sign in front, because what if it was 4 plus 5 minus 6? Then it would be 4 plus 5 is 9, and 9 minus 6 would have given me a 3 there instead of a plus 15. So definitely include the signs when you're combining your like terms, and you just combine your coefficient. If it's a plus sign, add them. If it's a minus sign in front of your coefficient, subtract them. Which one of these look the same? Right here, 3x plus 15, 3x plus 15, and another 3x plus 15. So A, B, and D all are equivalent to each other. Okay, for the next one, it says Coach Jensen is coaching tennis. He will need to buy a new tennis racket and many cans of tennis balls. The racket costs $100 and each can of tennis balls costs $4. Write an algebraic expression for how much Coach Jensen will have to spend. So I have a one-time fee of $100. Then you have an additional cost of $4 per can that you buy. So this or 4C plus 100. Okay, both are saying the same thing. You don't have to have C for can. You could have had 4B to represent the balls or 4T for tennis balls. Okay, as long as you have 4 be multiplied by a variable plus 100. Okay, you're fine. So there's your expression, either one. And you didn't have to use that variable because they didn't specify. And then the next part says if Coach Jensen buys 10 cans of tennis balls. So I'm going to say that this was the expression I wrote. And how many cans did they buy? They bought 10 cans. So I'm going to replace the C with a 10. And everything else stays the same. Well, 4 times 10 is 40. So you spent $40 on the tennis balls plus $100 for the racket. So $140 total. Done. Okay, and then some years we go over this, some years we don't. So this might be a year that we skip it, or it might be a year that we include it. Hopefully some of you guys covered it in elementary school. If not, just do your best guess, or if it's a year we didn't cover it, don't worry about it. Okay. Identity property means it keeps its sense of self. So if it starts as X, it ends as X. So what can you add to a number to keep its sense of identity? You add 0. Or what can you multiply by a number to keep its same identity? You multiply by 1. It doesn't change it, right? Like 7 times 1 is 7. 5 times 1 is 5. 5 plus 0 is 5. 7 plus 0 is still 7. So it keeps its sense of self. This is known as the identity property. Okay, let's skip up here. Let's look at the associative property. The associative property, think of business associates. It's who you associate, who you hang out with. So the number inside of the parentheses, which are known as grouping symbols, changes. So the groups change. Who's inside of the parentheses change. Which number is that? Here, A and B are hanging out, and then all of a sudden A is like, sorry, I don't want to hang out with you anymore. And so then B starts hanging out with C instead. So here B and C are hanging out versus A and B were hanging out. So sad A got dumped by B and B started hanging out with C now. That's the associative property. Who you associated with changed. This is the associative property of addition. This is the associative property of multiplication. Okay, this one. Actually, no, let's move to this. Okay, let's define the commutative property. The commutative property means that the numbers change order. They commute from one place to the next. So it'd be the same exact thing on both sides, and the number doesn't change the order. So ABC, it's still ABC, right? It was just who was associating with who that changed. But here, it was A, then B, and now the order changed. They commuted from one place to the next. So if the numbers change order, that's known as the commutative property. If the numbers inside the parentheses change of who's hanging out with who or who's associating with who, that's the associative property. Okay, but the order stayed the same. Distributive property, I took this A and I distributed it to the B and got AB. Then I took the A and I distributed it to the C and I got A times C. There you go. If there's a plus sign between it, put a plus sign. If there's a minus sign between them, put a minus sign. So C is known as the distributive property. All right, guys, you have now mastered mods 9 and 10. Congratulations.